Hi, everyone. And everyone having coffee over there, feel free to wander over whenever it makes sense. I'll try and make it make sense halfway through as well. Hi, I'm Meryem. I'm the co-founder and CEO of TitanML. Really excited to be here. OK, so picture this. Within the next 10 years, the first eyes scanning any document in your organization won't be human. They'll belong to AI. And that's a pretty outlandish claim, considering how far away we are from that right now. And there are very legitimate concerns about privacy and security and scalability, like how do I even build AI at the scale where it can read all of those documents? But there's very good reason why I think this will happen. And it's our job as the people building the data and AI future to make that happen. I'm Meryem. I'm a firm believer in the potential of AI, not just for productivity gains like we've heard about earlier today, but also for massively enhancing the potential of human creativity. And today, I want to talk to you about what it looks like to have AI everywhere. Not just everyday AI, but absolutely everywhere. And there's three things I'm going to mention today. So the first thing is I'm going to justify my pretty outlandish claim that we're going to have AI reading all of our documents before people do. I'm then going to talk about what it means to have differentiated AI, given that. And this will come on from what we've heard about this morning. And then thirdly, I'm going to talk about how we can get started today. So how can we take that first step towards the pretty scary prospect of having AI everywhere within our organizations? So let's start with envisioning AI everywhere. So why do I think that we're going to have AI absolutely, completely embedded in our organizations? And to talk about this, I want to talk about two different kinds of data. Structured data, which is probably where most of you guys spend your time, and it's probably where the reason why you're working with Dataiku in the first place. Structured data is pretty much anything that you can represent in a chart or a graph, whereas the data that I want to talk about today is unstructured data. So this is the data in reports, in emails, in images, in phone calls, in everything else that your organization has. And the vast majority of the data within your organization is this unstructured data. Now, what's interesting is despite it being the vast majority of where our proprietary and, and company knowledge is stored, we're really, really bad at analyzing it. So with structured data, we have a bunch of different ways we can analyze this and gain insights. We have reams of toolings that we have. So we have entire data engineering and analytics platforms. We have financial modeling for your financial data. We are very, very good at analyzing structured data. But for unstructured data, we are really, really terrible. Essentially, the only thing that we have is manual processing. But the issue with manual processing is there's too much data for us to be good at processing it en masse. We expect people to make the link between an email they got last week and a report they read a month ago and the conversation they're having today. And that's just really not very sustainable. So we end up with a lot of missed information and slow analysis. But what's good is that AI is really, really good at understanding this part of our data set. So if we want to go into the future and we know that this unstructured data is the vast majority of the data that we have in our organizations, and AI is really good at analyzing it, it's a no-brainer that we're going to have AI look at all of the information that we have in our org before people do. Because it allows people to focus on the links that really matter and that really key information. So we're going to have AI everywhere. What does it mean to have differentiated AI everywhere? So my claim is that AI will be differentiated because it has access to your proprietary business-critical data. The thing that makes your businesses unique is the data that you have and the know-how that you have. And for some of your applications, we're going to have to think about, OK, if it's going to have access to this proprietary business data, what does that mean for the ways that I need to go about building it? So broadly, there's two ways that you can access your AI. And we've touched about this a bit earlier on when they were talking about the LLM mesh. So there's the first way, which is the API-hosted way. And actually, the vast majority of POCs are built on top of APIs like OpenAI and Anthropic. And the way that it works is you essentially have an internal microservice that's calling out to a third-party system. So the actual models and compute is hosted in someone else's environment. The alternative option is to self-host. So this is when all of your models and all of your data stay within your own four walls. So it stays within your VPC, your on-prem data center environment. And for some use cases, that is really, really valuable, because you have those private deployments, so you can deploy within your own environment, which is crucial if you're going to be having your models look at this really, really sensitive data. You can achieve AI independence, so you're not dependent on third parties, which is critical if this is going to be an application that is going to be really instrumental to the way your business works. And you also have that total control. So you control the model, you control the tool chain, you decide when the model's upgraded to the next version, and vice versa. So building the capabilities to do this self-hostedness, or this self-hosted thing, let me go back, is really important. So I've now gone through I've justified where we're going to have AI everywhere. I've said that if we're going to have AI everywhere, it's going to touch our proprietary data, and for some of that data, we're going to need to self-host. So it might be worth talking about what are the capabilities you need to be able to self-host. So we should start with the experience that you have working with an API-based model. Out of interest, can I have a show of hands for anyone that has played with an API-based model? So an OpenAI or an Anthropic or anything like that? OK, so actually a good chunk of people. So when you're interacting with it, it's very simple. You have essentially query and response and API. Pretty simple. But when you're self-hosting, there's an entire iceberg of things that you don't see going on behind the scenes. So why don't we go through just a few of them? So the first thing you need is a batching server. So this is how your requests are processed. There are different complexities. So some batching schemes will work for some models and not others. So for example, you'll have dynamic batching for embedders, and then continuous for generative models. But let's say I have my batching server. I then need my server to call into some kind of model, which is actually where the magic happens. Unfortunately, there's loads of really fantastic open source models, and they're getting better and better by the day. There's some complexity there, though, that running these models out of the box will lead to very slow and expensive inference. So I then need to figure out a way to make it faster. So maybe I'll have some kind of inference optimization or runtime engine, speculative decoding, that kind of thing. Complexity there is still probably needs a really large GPU, and that's why our friends at NVIDIA are very, very wealthy. So then I might do some kind of memory optimization, something like quantization. Maybe I'll distribute my models over multiple GPUs. There's some complexity there. There's lots of different quantization types. But then I'll deploy all of this on a GPU. So I have my requests come in, goes to a batching server, goes into some model that I've optimized, sits on some Kubernetes cluster with some GPUs. Then maybe I want to make sure my outputs are in the form that I care about if I'm doing structured outputs. So I'll have some kind of model controller, and then all the normal logging and monitoring that we would have anyway. So this is pretty complex, but there's really good reasons that you might want to do it. Total privacy. At scale, it's actually much cheaper. You have control over your AI, and you have that AI independence. But you have that significant expertise, very costly if it's done wrong. You do get some infrastructural sprawl, and it's difficult to swap models. But nobody said it would be easy. Is anyone here a Coldplay fan? That's my karaoke song. Yeah, nobody said it would be easy, but also nobody said it would be this hard. So let's figure out how we can get started today, because we do need to be able to build up the ability to put our proprietary data into these models, because that's what will make it differentiated. So this is a nightmare, and nobody should have to deal with it apart from people whose job it is to deal with it. For most people, your job is to create differentiated value-adding applications. So this is what we do. Oh, I'm so sorry. This is what we do at TitanML. We provide all of that infrastructure so you can have the experience of working with these private self-hosted models in the same way that you interact with these API-based models. So we start with your environment. We don't have a cloud. We have no intention of having a cloud, so we only ever deploy it in our clients' environments. We deploy a container that has all of the inference stack that you need to be able to deploy these self-hosted models really efficiently. And then you can deploy multiple models inside that container. So not just your generative models that everyone's been hyping about, but actually to build a great RAG application or enterprise application, you probably need an embedding model and a re-ranker model and maybe even a table parser. All of that can go in the same container as well. And then you interact with it through an API. You interact with that container through an API, making that experience really, really seamless. So it's super easy to swap those models, and you have that best-in-class infrastructure always implied that's ready to scale when you're ready to scale, and it's also always optimized for our enterprise document processing use cases. So why do people use Takeoff? Well, private deployments is the main reason. Most of our clients are regulated industries, super high performance, higher performance than most people would be able to achieve if they're building it themselves. ML ops ready, and we also do a lot to minimize hallucinations. We have a lot there that makes that very easy. You might be wondering why I'm here. Well, we are now integrated within the Dataiku LLM mesh. So all of those wonderful models that you had access to before, you can now also get access to self-hosted models with Titan Takeoff, which means your experience of working within the LLM mesh can also include those privately hosted models. How does it work? Well, we essentially have it as just a model option. So it's very, very simple. And the nice thing about it is you have that complete control and security over your AI applications. That's something that we and Dataiku have in common. You can swap models really, really easily, minimize that complexity and infrastructure burden. And because you're using really great infrastructure from the start, it's ready to scale, so you can focus on building those great applications. So I'm almost done. You can connect with me on LinkedIn, because otherwise I'll have to get my phone out constantly. But we know that we're going to end up in a situation where we're going to have AI absolutely embedded within all of your organizations and with all your processes. And for some of those applications, they will need to be self-hosted. And it's important that you have the ability to self-host and the capabilities to self-host built up today. And Titan Takeoff within the Dataiku LLM mesh is a really nice way to get started with your very first self-hosted LLM project. And together, we'll move forward to a world of AI everywhere. Thank you very much.